This is Professor Derf Seitz. This Java tutorial focuses on interfaces. This is the class diagram for our illustrative example. An interface is a pattern of one or more functions that are intentionally not implemented. Its purpose is to establish a usage pattern that its implementer classes must implement. In this diagram, we have one interface, drawable, with the stereotype interface, and the drawable interface has two functions, draw side view and draw top view. Both of those functions are abstract. They simply define the signature, the name, and the parameters that implementers must implement. An interface can include static constants, abstract functions, and it can also extend other interfaces. All members of a public interface are automatically public. All fields in an interface are automatically static and final, they're constants. All functions in an interface are automatically abstract. Therefore, an interface itself is automatically abstract and cannot be instantiated. You use it through an implementer class, which implements it. We have two implementer classes in our example, a motorboat and a sailboat. The dashed line with the arrow on the end is the symbol used for the realization relationship, and that's what's used in a class diagram to show an implementer that's implementing an interface. Notice that we also have four boats here: canoe, motorboat, rowboat, and sailboat. All four of them are regular derived classes from a boat base class. In regular inheritance, you can only have one parent class. So these four boats have one parent through normal inheritance, the boat class. But when you introduce interfaces, it allows the classes to not only have a regular base class where they can stand in as a boat, but they can also stand in as a drawable if they implement the drawable interface. An implementer class is required to implement all the functions of its interface. Otherwise, it couldn't stand in for it. Let's zoom in now on this class diagram. Here's the drawable interface with the two abstract methods, draw side view and draw top view. Motorboat is one of its implementers. It has the draw side view and draw top view, whereas canoe is not one of its implementers. It does not have those two functions. And the base class up here also does not have those two draw functions. The base class has getters and setters for the hull attributes of the basic boat, which is just a hull, and also has a display specs function which the derived classes will override in order to display the complete specifications for the boats, because the child classes do add their own fields and their own getter and setters. For example, the canoe has number of paddles, the motorboat has horsepower, the rowboat has number of oars, and the sailboat has the height of the mast. Here we're looking at the source code for the drawable interface. The keyword interface is what declares it to be an interface. It has the two functions. Notice that neither function has any implementation. They don't even have braces, because the implementations must be provided by implementer classes. The annotations here for the class, the annotation for the interface says it has implementations. The annotation for the two methods say that they have implementations in this package. Looking at an implementer class, Sailboat, well, it's also derived. Sailboat here extends boat through normal inheritance, and it implements the drawable interface. We can see that down here, there's the draw side view and the draw top view that are provided in the Sailboat implementer class. Looking at the boat interface client, which will exercise these classes, in its main method it has an array list of boats. We are going to add 4 boats into that array list, one of each type: a canoe, a rowboat, a motorboat, and a sailboat. We add those to the list, and then we have an enhanced for loop that will iterate through that list, and for each boat we'll display the specifications of the boat. This if statement here says if it's not true that the boat is an instance of drawable, then we want to continue. Continue immediately goes back to the control statement up here, the controller for the for loop, to go to the next boat. It will not continue down through the end of the for loop. If the boat is an instance of drawable, we would go into this code down here where we will print the side view and draw the side view and the top view. Notice that in order to call these functions, draw side view and draw top view, we have to take the boat base class reference and explicitly cast it to a drawable interface reference. Interfaces can stand in anywhere a normal reference type can stand in. Be very careful here as well. Normally you have parentheses around the explicit cast, but in order for this to work, to compile, you have to have another set of parentheses preceding the dot operator that separates the method call from the object. Let's go ahead and run this. Scroll up to the top of the output. We see our canoe called Mohican with its dimensions and information. No drawing occurred for canoe. It was not capable of doing that. Rowboat, same thing. Its name, dimensions, specifications. The motorboat, however, after it shows its specifications, it draws the side view and the top view, and the sailboat likewise, because both of those are capable, they're drawable, and in the for loop they go down to that bottom part of the for loop where those interface functions are called. Going back to our class diagram, we now can more clearly understand this concept of interfaces providing a multiple inheritance-like feature, because we've seen now some boats that not only can stand in as a boat, but also can stand in as a separate type, separate from boat, called drawable. A key difference between regular inheritance and the interface implementers is that in regular inheritance here we can reuse the actual code from the base class, where with the interface there isn't any code, it's just the interface itself that you're reusing. So that's a difference, but given that we can combine both of them, we can reuse from a base class and we can implement the interface and then stand in any place where that interface is being used. We have a lot of flexibility in our designs.